Thank you, Martina, for the introduction, and thank you for inviting me here today. Okay, few words about Versalis. Versalis is the chemical company of Eni Group. We have 26 production sites, mainly in Europe, but with presence commercial and industrial in America, India, and Far East. Versalis has a very spread technology portfolio, from basic chemistry and polymer to new platforms such as bioproduct, compounding, and circular product. Versalis' strategy is more and more focused on the growth of such new platform by reconversion of our industrial site to grow in biochemistry, circularity, and compounding. We have started this very ambitious journey. We strongly believe in this conversion of our industrial footprint. As mentioned a couple of times today, to successfully reduce the amount of plastic waste, it is necessary to implement complementary recycling technology. So here we mentioned mechanical recycling and chemical recycling, that are the technology we are working on. On mechanical recycling, we start from selected plastic waste, and we have developed the technologies and products for high-value application up to food contact application. On chemical recycling, that is the topic of today's presentation, we have developed our own chemical recycling technology, so-called UP technology, that's starting from mixed plastic waste to produce a new feedstock for production of polymer that are exactly equivalent to virgin one. So the name of the project is HOOP. HOOP is a development on industrial chemical recycling technology via pyrolysis. We are talking about thermal pyrolysis. Chemical recycling via pyrolysis is a process that foresees two main steps. The first step is the preparation, means that we start from mixed plastic waste, residual from sorting processes, we need to select this waste to remove what is not plastic and has been inserted by mistake in the plastic waste, and some unwanted plastics such as PVC. Then we have some grinding and compaction processes to provide an homogeneous physical form to the feedstock for the core of the process, that is, of course, the pyrolysis, where we have the thermal cracking of the polymer into an hydrocarbon mixture that is a new feedstock for production of polymer in existing assets. The project has been developed with three main targets. The first is, of course, maximum material recovery. That means maximum recycling rate, but at the same time, maximum carbon that remains into the cycle and is not lost as CO2 in atmosphere. We reached this target with a process yield that is higher than 80%, producing one single liquid product with quality similar to fossil raw material. Second is flexibility on raw material that we can process. We start from a mixed waste that is heterogeneous by nature, so we have to be able to process and keep the quality considering the variation of the feedstock. We can do this by applying some proprietary technologies that allow us to continuously monitor the feedstock entering into the pyrolysis reactor and in a way adjust the operating condition to keep the yield and the quality as high as possible. Third target is, of course, the minimum environmental impact. We have worked along all the value chain to minimize the environmental impact on the process, and we have developed the process that is easily integratable with renewable energy sources. We have started this project in 2020 with a co-development with an Italian company called Servizi di Ricerca e Sviluppo, SRS. We started from their consolidated know-how on pyrolysis of mixed plastic to fuel, and we developed, starting from this know-how, a new technology, a proprietary technology for chemical recycling, so for produce a feedstock for polymer production from mixed plastic. We have just completed the construction of a demonstration unit, a semi-industrial plant of 6,000 tons per year in our industrial site in Mantova. And of course, this is a fundamental step for the successive passage of scale in our industrial site. In this slide, you can see a very simplified scheme of the process. A couple of key features of this technology is a two-step pyrolysis reaction with an advanced heating system that allow us to have the best quality and yield of the oil that is the feedstock then for the steam cracker to produce new monomer and then new polymers. How we have developed this technology? We have done very extensive experimental activities working on each aspect of the process, starting from the mixed plastic waste. Is heterogeneous, as mentioned before, so we have characterized very different plastic waste from different sources, and we have evaluated the effect of the composition of the raw material to the final result. We have tested it in lab-scale pyrolysis reactor. We have produced, of course, oil, and we have tested the compatibility with virgin naphtha in a pilot steam cracker. As mentioned before, we have to use existing asset, and we have to co-feed this new sustainable feedstock with traditional feedstock, so we have to be able to do so. Also, this has been mentioned a couple of times today. Chemical recycling means a reduction of CO2 emission to atmosphere. This is linked to two main aspects. First, of course, is the substitution of the fossil feedstock with the sustainable feedstock. And the second is that we avoid the incineration of, or the energy recovery of the mixed plastic waste that, as we have seen also this morning in the opening, it's a very big part of the collected plastic waste. By avoiding this incineration with chemical recycling, we reduce very much the CO2 that is lost to atmosphere. This has been recognized also by the European Union. In fact, our project in Mantova has been awarded with the EU Innovation Fund. This is a significant achievement for us in order to scale up the process and continue working. On the left side, you can see a summary of the step of the process. So mixed plastic, then we prepare the feedstock. The pyrolysis technology converts it in recycled oil or recycled naphtha that is fed to chemical plants to produce a new virgin polymer exactly equivalent to virgin 1. In the right side of the slide, you can see an aerial view of our demonstration plant in Mantova. As you can see, it's a semi-industrial unit. We are starting it in these days, and this is for us a key step for proceeding in the industrial application of this technology. Thank you very much.